Welcome to Spring LIB.
Okay, so we're doing chapter 23, problem 41 here. So it says suppose the flat circular disk of figure 15, which was example 23.9 in your book, we have drawn here, has a non-uniform charge density where sigma is given by AR squared, and R is measured from the center of the disk. And we want to figure out what V of X is along points along the x-axis if V equals 0 at x infinity. Okay, so we're going to follow the same example where we know that we can express the potential as an integral 1 over 4 pi epsilon naught times the integral of dq over r. So from this we know that dq in terms of surface density is sigma dA. We can now write what this comes out to being. If we plug in what sigma is, that's AR squared, and dA is the differential of our area function, and that becomes 2 pi r dr. If A is pi r squared, dA equals 2 pi r dr. That's how we get that. So this becomes our dq, so we can plug that into our integral. 1 over 4 pi epsilon naught integral from 0 to r naught of ar cubed times 2 pi dr. And this is over r, but we know we can write little r in terms of x and big R as given in the figure here. So let's write that out as x squared plus big R squared. So let's go ahead and simplify some things, and we're left with a over 2 epsilon naught integral from 0 to r naught dr r cubed over x squared plus r squared to the 1/2. Okay, so now comes the tricky part where we take x squared plus r squared to equal u squared and do the substitution. From this we should see that dr equals 2u equals u over r du. So let's go ahead and do our substitution here, and I'll add a new page to make this a little bit simpler. We have a over 2 epsilon naught integral from 0 to okay, let's do this. R equals 0 to R equals R naught. This will be simpler because we need to change our bounds eventually, same way as we did our substitution, but we can wait for that for a second. And this becomes u squared minus x squared u du over u. So these cancel, these u's, and we can easily integrate that. And this becomes a over 2 epsilon naught, and we have 1/3 u to the cubed minus ux squared. And this is evaluated at r equals 0 to r equals r naught. So now we just plug back in what u equals, which was x squared plus r squared square root. And we see we have a over 2 epsilon naught, and then we have 1/3 x squared plus r squared to the 3/2 minus x squared times x squared plus r squared to the 1/2. And this is evaluated from r to 0 to r to naught. So last thing we got to do is just evaluate it and simplify, and it comes out to being v of x equals a over 6 Oops, let me just rewrite that. 6 epsilon naught times r naught squared minus 2x squared times x squared plus r naught squared to the 1/2 plus 2x cubed. Awesome. Lots of integral fun here, but we made it to the answer.